This is the second of two videos on series and parallel circuits. The first video was on series circuits. Now we want to concentrate on parallel circuits. Parallel circuits look like this. You have a power source or a battery, and then the difference, which you should notice immediately, is that the resistors are in fact in parallel. You can see the parallel lines here. The battery, of course, is here. And you should also notice that there's more than one pathway for the electrons to flow through. When we were looking at the series, there was only one pathway, but you can see that the electrons can go this way or they can go this way. They could go this way or they could go this way. And again, they come back together down here at the bottom to go back in at the bottom of the battery. And so parallel circuits have more than one pathway. Now, well, let's put some numbers in right quick. We've got a 6-volt battery. Let's make this a 3 ohm resistor and a 6 ohm resistor and a 2 ohm resistor. And so we've got 3 resistances in parallel. Now, before we work that problem, one of the things, let's go back and talk about some of the rules for parallel circuits. Of course, Ohm's law applies for all circuits, and we said that I over 1 equals V over R, and so that's Ohm's law. Secondly, but different, is the resistance. The resistance is inverse, or it's the reciprocals. So we have 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and however many resistors are in parallel. But notice that they all are the reciprocals, 1 over the value. And so you're working with fractions, and one of the key factors in working with fractions is you have to have a common denominator. Now, when I get to the point where we're going to work these, I want you to pay real close attention, because there's another little thing where once we get the answer for the fraction, then we have to flip it over. You'll see what I'm talking about when we get to the numbers themselves. Another thing that we need to know about this is that it's the voltage is the same everywhere. If you'll remember, in the series circuit, it was the current that was the same everywhere. On a parallel circuit, it's the voltage that's the same everywhere, which means that we can measure the voltage at any given spot and it will be the same. But the current is going to vary. Let's say the current will vary with resistance. Now, one of the things that you probably have heard before is the idea that some things will take the path of least resistance. Well, it's true in electricity also, where the resistance is small, the current will be large. And inversely, where the resistance is large, then the current will be small. And so they're inversely proportional to each other, and we're going to see how we can work this problem to get that. But don't try to do that thing with current like we did in the series circuit, because it won't work the same way. You'll get some answers that will maybe confuse you initially. So let's talk about how we do this. If we solve for R total, we've got 1 over R total is equal to 1 over 3 plus 1 over 6 plus 1 over 2. Okay? And so you're looking for the common denominator, and everybody should be saying that's 6, which is easy. So this is going to be 2 6, and this is going to be 1 6 still, and this is going to be 3 6. When we add that up, it comes out to 6, 6. So 1 over R total is equal to 6 over 6. Now, it doesn't really matter in this particular situation mathematically, but I want you to get used to this. I want you to flip it. And what I mean by that is RT over 1 is equal to 6 over 6. Now, it doesn't look like those numbers have changed, but we put a star next to that 6 right there, that 6 becomes that 6. Now, mathematically, it doesn't make a difference, but I want you to see that we did flip everything. We flipped the letters on this side and the numbers on the other side. So now we know that our total is 6 over 6, or the value of 1. So our total is 1. We've got a 6-volt battery. So if we do Ohm's law, we've got 6 volts over 1 ohm is equal to I over 1. And so you've got 6 amps of current coming out of that battery. One thing that you should be aware of and that you should log away in your brain is that all parallel circuits usually end up with high current flows. And when that happens, that also leads to increase in temperature for the wires and the resistors, and it also could cause the light bulbs to blow, et cetera, because the current is so high. So we've got to be, there's a safety feature that goes along with parallel circuits. Now, if I change colors right quick, and it's not a big color change, but we want to solve for I1, I2, and I3. And the reason that we do that is because each one of those pathways has a different amount of current. Okay? But another thing that we could say is that I1, I2, and I3 should add up to the total current in the circuit. And so I have something that I call the loop rule. The loop rule says that each loop gets the same voltage. So we're going to say this loop gets 6 volts right here. And then this loop gets 6 volts. And then this loop also gets 6 volts. Well, this should look awfully much like that same thing that we had here in Ohm's law, where there's voltage divided by current, or by resistance, excuse me. And so 6 divided by 3 is 2 amps. 6 divided by 6 is 1 amp. And 6 divided by 2 is 3 amps. Now, if we add those up, 3 and 1 is 4 and 2 is 6, which corresponds with the total current that was supposed to be in the whole circuit. And you can see that all those are going to come down and to the left, down and to the left, and down and to the left. And so they're all going to add back up as they go back into the battery on the negative side. Now, if you have any questions about this, email me and we'll try to get it cleared up. Thank you for watching. Have a great day.